Yeah, thanks. Good morning. So the next session is dedicated to Beamline control. And our first speaker is David Perl from Diamond Light Source. Please come. Andy.
That's the trick. You got to be.
Yeah, we have to use Firefox. I mean, for the. Okay.
And then you can use that. Okay.
Yeah.
Hello, everybody. I'm David. I am a data acquisition software developer at Diamond. And for the last couple of years, I've been working in a small team on this project to do very high throughput macromolecular crystallography data collections, and using Blue Sky and Ophid to implement that. So there's a few beamlines at Diamond which do completely automatic, unattended data collections. So users send us their crystals frozen in liquid nitrogen. A robot puts them onto the beamline. A automated process finds the center of the crystal, and the data is collected from them. And some of the data processing pipelines are also automated. So the user submits their sample and says what kind of information they want out of it, and sometime later they get an email saying that their data has been collected, and they never see the inside of the synchrotron. This is mostly used for drug discovery when the fundamental structure of the protein is already known, and you want to see how some small molecule interacts with it. You want to see how thousands of different small molecules interact with that protein. So you don't need the absolute best data quality in this case. You just need good enough data quality and as fast as possible, as many different structures as you can cram into a day. So the way that the data collection process works is fairly straightforward. The beamline needs to start in some state where we more or less know how things are. We get the information about what the experiment is that we want to do from the database where the user has submitted it. We get the robot to put the sample on the beamline. We draw a grid over the crystal and take an X-ray exposure at each of those positions, and use the intensity of the diffraction signal to figure out where the best part of the crystal is, and then we go to that spot, and then we do a rotation of the crystal while it's being exposed to the beam, and potentially do that a couple more times at some different angles, and then we move on to the next sample. And that series of instructions is by far the smallest part of the entire software program. What's actually more involved is getting all the metadata out into the right place, and reading back and forth from the database what things we want to do, and triggering the processing, and making sure that this is all reliable, and writing the files in the right formats. Takes much more time and more code. So this project was basically our test case for evaluating whether we want to use Blue Sky for all of our upcoming software as we're upgrading the synchrotron. And we are particularly interested, for the sake of this project, in the way that the data management is separated from the experimental instructions. So when you write an experiment plan in Blue Sky, you just sort of send a sequence of instructions, and in a separate process, your metadata about what happened during the experiment can be used to do all the extra stuff, like interacting with the database and doing the finicky things that aren't really part of your sequence of instructions for your experiment. So the software in the end looks sort of like this. So we are replacing. We built this sort of step by step, and so we have this functionality, this automated data collection, already in our legacy software in GDA, but it's very, very slow, and it does a lot of unnecessary sort of things that were designed as safety features when real users were controlling the beamline. So it will, every time that you do something, it will move the apertures in and out just to make sure that they're in the right position. It will move the beam stop in and out just to make sure that the beam stop is there, because we don't know whether a user has been clicking buttons somewhere on the screen. But when we're doing automated data collection, we do know that nobody has been clicking any buttons, and so if we left the beam stop in place, then it should still be there the next time, and we don't really need to check it. And so that has been the main sort of reason for the speed up due to this process. And so what happens is that we get our instructions from the legacy software, and we pass over what those are to our collection of Blue Sky plans for centering, for loading the sample, for doing the rotational data collection, and then the experiment metadata is exported from there over a ZMQ stream to the routines which handle creating the Nexus files and creating the database depositions, and all of the analysis software just watches the database, and when new experiments appear there, then they get processed. So currently, all of the actual experimental parts of this are finished in Blue Sky, and the original deposition of the data is still in our old software. So I want to talk, because we think that this has been a fairly successful project, at least our users, our Beamline staff, are really happy with it. I'm going to just talk a little bit about our development strategies for it. We tried to more or less stick to a sort of Scrum approach, except where it didn't work for us because our team was very small, often only 2 people. It doesn't really make sense to have a full-time product owner if you only have 2 people. But we did find that this way of managing bite-sized issues in this way and tracking them using the GitHub project management system, we did find that it worked really well for us. In particular, having after our sprint planning meetings a sort of technical discussion meeting where we hash out in a few hours the technical approach that we will take to implementing a particular ticket means that anybody was able to pick anything up, and people didn't necessarily get too stuck on working on their own little part of the thing, and everybody got some experience across the entire project and felt able to take on any ticket that was available, and that allowed the prioritization of work to go really well. I just want to tell everybody to write tests. It's good. They catch a lot of errors. We should do it more often. We originally thought that we would have a separate repository for OFID devices, and then a separate repository for sort of common MX code and then a separate repository for application code. In the end, because all the main branches of all of these projects needed to be constantly in sync with each other in order to be able to run tests in CI, the dependency management became extremely complicated. And so we actually decided to move all of our applications into one repository. But we may revisit that if they become more stable over time. Recent news from the last few weeks is that we now are deploying this into a per Beamline Kubernetes cluster. And so hopefully that will give the scientists more options to change versions if something isn't working for them, or to just to roll out fixes in a more streamlined sort of way. We deploy the execution environment, the Python virtual environment, in a container running in the Kubernetes cluster, and then it still looks at code on disk in the shared file system to actually run the software. So we are still also able to make quick changes when something is needed immediately on the Beamline. But we have that sort of reproducibility for the environment that the software is running in. And I guess I want to finish just by saying that the main metric for our success here is that we have doubled the throughput of the IO3 Beamline, because this software is easier to write with, easier to move things around, and I guess because it's new. We were able to get rid of a lot of the clunky and slow and redundant processes that were there in our legacy software, and run a lot more data collections for a lot more scientists.
So we have time for question. Let's take the closest.
Okay, thanks. Actually, two questions. One very short. Do you use test-driven development? And
We leave that up to the whether it's really test-driven development or not is up to the developer. But we do enforce minimum coverage, and that tests must go along with any pull requests. So some people in the team prefer to write tests first. Some people will write them, at the same time or even afterwards. But we do enforce that they are merged.
Okay, a quick question here.
Near the end, you said that your Kubernetes cluster was per Beamline.
Yes.
So is that a unique cluster per Beamline, or one pod on each Beamline?
Three machines or like 3 nodes on each Beamline with a central control plane.
Okay. All right. Thank you.
And there was a quick question there. Hopefully.
How do you separate configuration and logic in your deployment?
Which kind of configuration?
So the logic about how the Beamline operates versus the configuration, what is the difference between one Beamline and the next?
So this application only runs on one Beamline, so it has a lot of assumptions about that particular Beamline built into it. The next step of this project is to make it sort of more generic and try to extract out some of those things.
Sorry, we don't have time for more questions. Thanks, David, again.